Is it visible?
Yes, sir.
Yes.
Great.
Hello, everyone. Thank you.
Hi, hi, hi. Good evening. Let's start with
Good evening.
most commonly used dynamic routing protocol in production. In enterprises, service-wide network, in data center, in ISP, everywhere. OSPF is most commonly used IGP protocol. And we are not going to use OSPF alone in the topology, right? After few classes you will see we are running multiple routing protocols. Multiple means OSPF plus BGP together, and most of the things are connected, right? You are going to configure both the protocol in single topology, means both are dependent on each other. When OSPF will work well, then only BGP is going to work well. We have understood EIGRP or whatever other concepts we have in the routing, like a static routing, dynamic routing. Those are important but not commonly used in the production network. EIGRP is not commonly used protocol, dynamic routing protocol. Sometimes we are using in some specific scenarios like our DMVPN. In some cases you will see EIGRP works better than OSPF, but in more than 95% scenarios your IGP protocol is going to be OSPF and your EGP protocol is going to be BGP, right? And after OSPF BGP also you will see the other protocols are connected with my underlay, like with OSPF plus BGP. Like later you are going to understand MPLS or VPN, right? You will see the VPN is only possible when we have underlay reachability, and for underlay reachability we are running OSPF dynamic routing protocol, a very important routing protocol even for the interview, for exam, right? For working professionals, OSPF is one of the most important dynamic routing protocol. We have to understand each and every concept in deep. We have to go in detail so that if there is any issue in the network you can troubleshoot it, right? So that if there is any issue in the design you can redesign that, you can reconnect the devices. Like if I have 4 sites, for an example, 4 sites means I have 4 routers. So if I
Sir, is
want
it
to,
recorded?
yes,
Okay, thank you.
if I need to connect these 4 sites together, I can connect like this also, or I can connect like this also. This is one scenario. Or instead of connecting like this, I can place one switch here, L2 switch, and then I can connect like this, right? In the campus network as well, right? When I have 4 routers, I can connect like this also, or I can connect all the routers directly with each other. So these are 2 different scenarios where OSPF is scalable, where OSPF is going to give best performance, right? That is our correct network design. So we have to understand these routing protocols like OSPF, BGP, how to enable in my network to get the best performance, right? And it should be easy for troubleshooting as well. Like if there is an issue, you should be able to troubleshoot the network easily. You are not going to make the configuration or design complicated, otherwise it will be difficult to troubleshoot. First of all, like other routing protocols, EIGRP or any switching protocols, STP, right? In STP, there are some elections for root bridge. For that, switches exchange BPDU, EIGRP exchange hello message, right? With the help of hello message, 2 routers become neighbor, and then they exchange database, means routing table. Similarly, we have to understand how 2 routers in OSPF going to form neighbor. How 2 routers will become neighbor. OSPF stand for what? OSPF stand for what?
Open shortest path first.
Open shortest path first. See, open shortest path first. Open means it is an open standard protocol. Open means it is an open standard protocol. We can run it on Cisco devices as well as on non-Cisco devices. And shortest path first is an algorithm. Like EIGRP uses which algorithm for best path selection? Dual algorithm. Similarly, OSPF uses SPF algorithm. What? SPF, shortest path first, and it is open standard protocol. That's why we are saying open shortest path first. Right, like dual algorithm work in EIGRP, dual algorithm calculate FD, RD, successor, feasible successor. Similarly here, we'll understand the formula of SPF to calculate the metric. EIGRP uses a multicast address 224.0.0.10 to send their message. As soon as you enable OSPF on the interface of router, you all know routing protocol doesn't work on router, it works on the interface of router. If I have scenario like this, R1, R2 and R3, here I can run two different IGP protocol. One between router 1 and router 2 means on this link, and one on this link means my dynamic routing protocol works on the interfaces, on the links between router. And always remember one thing, that limitation of IGP protocol, all IGP protocol is it works with connected devices only. The TTL value is in the hello message or update message going to be 1, right? So hello message, EIGRP hello message of router 1 cannot reach to router number 3. We can never have EIGRP neighborship between router 1 and router 3. If you have VPN kind of thing, definitely you can configure the EIGRP, okay, because then through VPN traffic from R1 can reach to R3 with TTL value 1 as well, okay. But here I can run two routing protocol, like in this segment, on this segment I can configure any routing protocol like BGP. In this segment I can configure any routing protocol like OSPF, right? Or let me say BGP and EIGRP and OSPF. Here I am running EIGRP, and here my dynamic routing protocol is OSPF. What it mean? It mean we have enabled EIGRP routing protocol on these two interfaces, on this interface and this interface of R1, this interface of R2, and we have enabled OSPF on this interface and this interface, okay. And router number 2 is border router, because one interface of router number 2 belongs to EIGRP domain and one interface belongs to OSPF domain. On one interface EIGRP routing protocol is running, on other interface OSPF routing protocol is running, okay. So as soon as we will enable OSPF routing protocol on any interface of router, what will happen like EIGRP? Tell me.
It will join a multicast group.
Which multicast group, sir?
224.0.0.5.
Sure? Are you sure?
Yes, sir. Maybe to both, or I'm not sure, but 2 to 5 will definitely it will join.
It is an IGP protocol. What it mean? What is the meaning of IGP?
Within AS only it will work.
Within AS it will work, or it will work with connected devices only. It is a link state routing protocol also. Can anyone remind me some properties of link state? We have discussed link state routing protocol. What it mean? What is the meaning of link state routing protocol? Tell me some properties. Like link state routing protocol maintain 3 tables. It sends full and partial update. It sends periodic and trigger message. Anything else? Here is the most important thing of link state routing protocol.
LSDP, right?
Yes.
Links,
Link state routing
LS
protocol doesn't share routing information. All distance vector routing protocol, even advanced distance vector routing protocol like EIGRP, share the route information, network information to their neighbor through update message. But OSPF or any link state routing protocol doesn't exchange routing table. What they exchange? They exchange database. What is database? Database is nothing but the detailed information of link, a state of link, you can say. Link state routing protocol exchange the information of links, a state of links to their neighbor. What it mean, Praful? Please explain here. Let me explain you. Let's say I have router number 1 and router number 2. Router 1 and router 2 both are connected like this, and on router number 1 I have some LAN subnet R1, R2, this is F0/0, and here behind R1 I have some LANs. You can imagine some loopbacks. Here my network subnet is 10.1.1.0/24. Here my subnet is 20.1.0.0, 20.1.1.0/24, and here my subnet is 30.1.0. or 1.1.0/24. These three are the LAN on router number 1. Let's suppose connected on loopback 1 interface, loopback 2 interface, and loopback 3 interface. Okay. If you are running any distance vector routing protocol here, or advanced distance vector routing protocol, means RIP version 2 or RIP version 1 or EIGRP, in that case router 1 is going to give the information of these networks to router number 2. Means router 1 is going to generate an update message, and in that update message it will include these prefixes, like I have a network 10.1.1.0/24, and it will share some k values, right? That router 2 can use that to calculate the metric, right? K1 means bandwidth. Hey, use this bandwidth to calculate the metric, use this delay to calculate the metric. That's all. Then 20.1.1.0/24 and 30.1.1.0/24, like this. There is no any information of router, right? Like router 2 cannot understand from where it is coming. It will know these all prefixes from their neighbor. That who is my neighbor? My neighbor is 12.1.1. Here IP address is 12.1, here IP address is 12.2. so my neighbor is 12.1, and I am learning these all prefixes from my neighbor. That means these all prefixes are reachable from router number 1. If router 2 is further connected with another router number 3, router 3 will learn these all prefixes 10, 20 and 30 from router number 2, from this neighbor, right? Router 3 will never understand that actual originator of these subnets, say these prefixes, is not router number 2, it's router number 1. Why? Because in distance vector routing protocol you don't have visibility of topology. All the routers are dependent on their neighbor. That's why in EIGRP we have query feature, right? Means whenever any prefix will goes down, router will ask to their neighbor if feasible successor is not available, because routers are dependent on neighbor. If I have topology like this, R1, R2, R3 and R4, and behind router number 4 I have destination network, or behind router number 1 I have destination network, right? Let's say one path is the good path, right, where we have more bandwidth, means list metric, and on one path, on lower path, let's say we have, this is backup path or worst path in EIGRP. Here let's suppose my metric is 10, metric is here let's say 20, here metric is let's suppose 110, and metric over here is let's say 220, and behind router number 1 I have LAN subnet 10.1.1.0/24. So router 1 is going to advertise this network information to their neighbor, right? If I am running EIGRP routing protocol here, my routing protocol is distance vector or advanced distance vector routing protocol. In that case, R1 is going to advertise this prefix to their neighbor, to router number 2 and router number 3. Router 2 is going to learn it via router number 1. Router 3 is also going to learn it via router number 1, and then both router 2 and router 3 will advertise it to router number 4. Router 4 will learn this prefix from router number 2 as well as from router number 3. It will calculate the metric, it will find lower metric via router number 2, so it will install the best path in their routing table. If feasibility condition will match, then it is going to install the backup path also, otherwise it will not install the backup path. Whenever router 2 goes down, let's suppose there is any issue on this link or on this device or on this link, in that case router 4 have to discover lower path again. If the path is not feasible successor, it is not available in the topology table, then with the help of query message router 4 will discover lower path. Why it's happening? Because router 4 don't have any knowledge of topology. Router 4 don't know that actually 10.1.1.0/24 is connected with one router whose ID is, let's say, 1.1.1 or any identification whose, let's say, host name is 1.1.1. That router is connected with two other router 2 and router 3, and I am connected with router 2 and 3, right? So there are two paths. This path is the best path because here I have lower metric. This path is not best path because here I don't have the low good metric, right? So router 4 will know the entire topology. Link state routing protocol knows the entire topology. Even by looking into the database of R1, you can design this entire topology. I will show you that also in today class only, how you can design entire topology just by looking into the database of any one router. So link state routing protocol means here you can see a router is going to maintain a database where it will store the state of link. Like in the database of router number 1, there will be informations like this. First, my router ID, advertising router ID. This is the first concept which we need to understand in OSPF. Router ID is nothing but the unique identity of router used for identification. So my router ID on router number 1, we can configure any router ID, or it will elect router ID automatically, dynamically. We'll see that also, how it is going to select router ID dynamically. For now, router ID is, let's say, 1.1.1. Then router 1 is going to say I have total how many links? Total I have 4 links. 4 links. Okay, then the state of all the link number 1, name, loopback interface, loopback 1, IP address on this interface is 10.1.1.1 or network ID 10.1.1.0, subnet ID or network ID. Then it will calculate the cost value. What is the cost on this interface? Let's say 10. You will learn how it is going to calculate the cost. Like this, it will store the detailed information of link 1, then link 2, then link 3 and link 4. It will store the state of all the links in their database, and this database is called LSDB, link state database. So meaning of link state routing protocol means the protocol which knows each and everything about topology. Later you will also understand one thing, that OSPF is pure link state routing protocol within the area. Between area, OSPF is distance vector routing protocol. Between area, OSPF is not going to exchange the complete database, right? Why we will do that? You will understand that also, right? To how to avoid the database size, how to summarize the database size, OSPF database size in my network through area concept. Later we will discuss that. Okay, is it clear? The link state properties. What is the meaning of link state routing protocol? Like distance vector routing protocol calculates metric based on hop count. That is the properties of distance vector routing protocol. Even that is the disadvantage of distance vector routing protocol, because it is not using link properties, but link state routing protocol calculates matrix based on link properties. It is going to use the bandwidth of link. So link state routing protocol calculates metric best path based on link properties, not based on distance. Like in distance vector routing protocol, shortest path will be the always best path, doesn't matter what is the link properties. That was the disadvantage. In OSPF, OSPF is a link state routing protocol. Later you are going to learn ISIS also. ISIS is also an link state routing protocol. All link state routing protocol exchange database. Note the prefixes. Now router 2, you will learn how router 2 is going to learn the prefixes, how it will like maintain the table, right? How it is going to make entries. Don't worry. But OSPF is a link state routing protocol. It means recall all the properties of link state routing protocol here. Then what is the protocol number of OSPF for packet flow?
89.
It uses protocol number 89, right? So in the IP header, we know we have some most important field like source IP, destination IP, TTL, and protocol, through which we can identify the upper protocol or the actual protocol. So protocol number is 89, right? 89 is reserved for OSPF, and it uses two multicast address. EIGRP uses how many multicast address? One. But OSPF uses 224.0.0.5 and 224.0.0.6. Question again, Praful, why it is using two multicast address and how it will be using two multicast address? Because in EIGRP we have seen how dynamic routing protocols work, only one multicast address is required. So in OSPF we have multiple types of routers. You are going to learn those all types of routers, right? And one is DR and BDR. DR is designated router and BDR is backup designated router. So those two are the special router types of router in OSPF. We'll understand that later. For now, your EIGRP uses multicast address 224.0.0.10. Similarly, OSPF uses this multicast address 224.0.0.5. All OSPF routers is going to listen on this address. All routers listen on this address 224.0.0.5. On 224.0.0.6, only DR and BDR router listen. Listen means if an interface has joined 224.0.0.10 multicast group, means it is going to receive that packet for that multicast address where destination is that multicast address, means that interface is member of that multicast group. So as soon as you will enable OSPF on any router, 100% that router is going to join this multicast group. And the special router DR and BDR only listen on .6. DR and BDR are two special types of router. These routers listen on 224.0.0.6 address. So in OSPF we uses two multicast addresses. Then it uses SPF algorithm. It uses SPF algorithm for metric calculation, for best path calculation, for best path selection. SPF algorithm. How SPF algorithm works, or how SPF algorithm calculate metric? Actually it uses a formula called metric equals reference bandwidth upon bandwidth of link. Again question, what is reference bandwidth? Let me tell you. Reference bandwidth upon bandwidth of actual link is called metric in OSPF. Now reference bandwidth is a reference value which you can configure on the router. Reference value is just a reference value to calculate metric, right? Like by default reference value is what on the Cisco router?
10,000.
100.
By default reference bandwidth is 100 Mbps. 100 Mbps means a fast Ethernet link. Fast Ethernet link will have what metric in OSPF? Fast Ethernet link will have what metric? Reference bandwidth 100 upon bandwidth of my link is also 100. It is going to be 1. And on gig link, what will be the bandwidth? Sorry, metric on gig link.
100 divided by 1000.
100 divided by 1000. It is going to be 0 point something,
0.1.
800.
right? It will consider that as 1 only. 0 point something will be 1 only. So bandwidth OSPF metric on fast Ethernet link is also 1 and on gig link is also 1. Why? It means we have not configured the reference bandwidth properly here. Right? If I will change the reference bandwidth from 100 to 1000, reference bandwidth is now 1000 Mbps. Now tell me on fast Ethernet link what will be the cost metric? 1000 divided by 100, it is going to be 10, and on gig link it is going to be 1, right? So based on your physical link bandwidth you will configure reference bandwidth. Okay, like if you don't have any link whose bandwidth is more than 100 Mbps, then you can use the default reference bandwidth. But if you have a link where bandwidth is more than 100 Mbps, then you have to change the reference bandwidth. Otherwise, a router OSPF will be calculating metric cost only one on all the links whose bandwidth is above 100 Mbps. Clear? So on the serial link, if you will check the cost of OSPF on serial link, then cost is going to be 64. You can calculate it. Reference bandwidth 100 divided by bandwidth of serial link, you will get 64. If you will calculate the cost on fast Ethernet link or Ethernet link, then on the Ethernet link cost is going to be 10. Right? I am calculating this cost value with reference bandwidth 100, the default one. On the fast Ethernet link, it is going to be 1. On the gig link also it is going to be 1. One reference bandwidth is 100 by default. Okay, and we can verify that also, like how we enable EIGRP through network command. Here you have two options. In two ways you can enable OSPF routing protocol on the router. First, through network command, like we enable on EIGRP or RIP routing protocol on the router. Similarly, through network command we can enable OSPF routing protocol on the router using network command. Second option, on the interface basis you can enable OSPF routing protocol, right? Because routing protocol works on the interface only. So on the interface you can run the command. Let me just draw two routers to have a simple topology. Here I can discuss basic things of OSPF. Let me connect them together and understand the neighborship, right? At the same time we can also understand the metric calculation. I can show you the reference bandwidth, the default reference bandwidth, even how you can change the reference bandwidth. But changing reference bandwidth is not important. You can find the command on internet. Why I should change the reference bandwidth? When I should change the reference bandwidth is important. You know, whenever we have links with bandwidth more than 100 Mbps, right? The reference bandwidth should be always greater than from the links where we have the, you know, like most high bandwidth configured, right? Reference bandwidth should be always lower than the bandwidth of link, then only you will get the exact value. Okay, so interface F0/0 no shutdown, IP address 12.1.1 255.255.255.0. Right now if you will check this interface, here my IP address is 12.1, here my IP address is 12.2 12.1.2, if you will check these interfaces, so these interfaces are not member of any multicast group by default. Port is set. I have configured the IP. So IP interface. So IP interface fast Ethernet 0/0. Here you can see the internet protocol address, broadcast address, proxy ARP and other things. But you can see this interface is not member of any multicast group. But as soon as I will enable OSPF over here, router, OSPF and process ID. See, on single router we can run multiple process of OSPF, and process ID used to differentiate the multiple process of OSPFs. Process ID is nothing but 16 bits decimal value. So range is going to be 1265535. Router OSPF 1. And like we enable any other routing protocol, dynamic routing protocol through network command, I am going to use here network command to enable OSPF on fast Ethernet 0/0. Network 12.1.0, wildcard mask 0.0.0.255, and then area, in which area you want to place this interface fast Ethernet 0/0. Soon we'll understand the area concept also. For now, just use area 0, which is the backbone area of OSPF. No worry about area concept, we'll understand it soon. Now see what will happen. This command is going to enable OSPF on fast Ethernet 0/0. Verify it through this command. So IP OSPF interface brief. This command will give you the information of OSPF on the interface. Like here you can see on fast Ethernet 0/0, process ID is 1, area ID is 0, IP address is 12.1.1, submit mask /24, and cost is 1. State is waiting. How cost is 1? Because this is fast Ethernet link and full reference bandwidth is 100 by default. So IP OSPF, here somewhere you can see the reference bandwidth. See how many times this router has executed the SPF algorithm. The algorithm one time only. Now there, whenever there will be any change, it will recalculate the SPF algorithm. And here you can see reference bandwidth unit is 100 Mbps. This is by default bandwidth. And do so interface fast Ethernet 0/0 include bandwidth. Here you can see the bandwidth of my link is also 100 Mbps. So 100 divided by 100 is going to be 1. Here we can see that. So IP OSPF interface brief. Done. Cost is 1. Now earlier state was waiting, but now state is DR. Earlier when I had run this command, then you can see here state was what? Waiting, and now state is DR. So DR and BDR election happens behind the scene, right? We'll understand that also, nobody. Now so IP OSPF neighbor. Here you can see so IP OSPF neighbor. We don't have any neighborship, and we can also verify the multicast group. So IP interface fast Ethernet 0/0. Now if you will check this interface, then you can see multicast reserve group joined 224.0.0.5 and 224.0.0.6. This router has joined both multicast group, which interface F0/0 of R1. Router 1 is sending hello message similar like EIGRP. We have hello message in OSPF also. The purpose is also same. First purpose to discover neighbor, and second purpose is keep alive. If you will enable debugging, debug IP OSPF hello packet, hello, then you will see router 1 is keep sending hello message to not router 2 from fast Ethernet 0/0. Router 1 don't know anything about router number 2. Who is router 2? Right, so you can see here it is sending OSPF process 1 hello message from fast Ethernet 0/0. Send hello message to which address? To 224.0.0.5, right? And hello message also carries some information like area ID. Here you can see If you want to see all the fields of hello message, then you can capture this link very easily through ISARC. You can see what are the content in hello message. Let me capture it and let me show you the base contents of hello message first. Here you can see hello message of router number 1, source IP 12.1.1, destination IP multicast address. So you can see as soon as I have enabled OSPF here, it has generated hello message, and this hello message is periodic. It is keep sending hello message. You can see periodic in nature. After every 5 second, 10 second, whatever, we'll see that hello message. 2, with source exit interface IP address 12.1.1 and destination the multicast address reserved for OSPF 224.0.0.5. Great. R2 is rejecting this hello message. Why R2 is rejecting?
No, it is not sending to .6 224.0.0.6.
Wait, bro. Wait. Router 2 is discarding it. Why? Because router 2 is not joined that multicast group. That's why router 2 is discarding this hello message. As soon as I will enable OSPF on router number 2 also, it will also join that multicast group. Then it will accept this hello message and router 2 will also generate their hello message. After that, both the routers are going to check some parameters similar like EIGRP. Like in EIGRP, K values must match, ES number must match, right? Subnet must match. Then only two routers can become neighbor. Similarly, here in OSPF, see the content of hello message. What are the contents? Open it, and here is the IP header. In the IP header, you can verify protocol. TTL value you can see 1, means it can OSPF can work with connected device only. Protocol number is 89. Source IP address is exit interface IP address. Destination IP address is multicast address of OSPF. Great. Let me close it and let me open the actual hello message. Here you can see in the hello message, first of all we have header information. Like in OSPF header, we have information of version, like which version of OSPF you are running, the type of message, right? Like in OSPF again we have multiple types of message: hello, DBD, LSR, LSU and LSAC. There are 5 types of messages in OSPF. In EIGRP also we have 5 types of messages: hello, update, query, reply and acknowledgement. In OSPF, hello, DBD, LSR, link state request, link state update and link state acknowledgement. So this is the very first message. Message type is hello packet. The length of packet, right? OSPF source router, source OSPF router 12.1.1 who is generating. Then area ID, in which area? In backbone area, area 0. The checksum field is there, symbol like checksum field in Ethernet header for error detection. After that, there is no any authentication configured on the router. Later you can also secure the OSPF routing protocol by configuring authentication. So hello message also carry the authentication information like authentication type and authentication data, means password, what password you have configured. Okay, so in the header we have seen version, types of message, length of message, source router ID, area ID, checksum, authentication type and authentication data. Let me close it and let me open the hello packet here. In the hello packet you can see subnet mask, hello interval, option field is there. In the option we have some flags, right? Later we'll discuss these flags like NSSA, not supported, multicast, not capable, external routing capable, multi topology routing no, right? So we'll discuss these flags later. Just for now keep it close. Here you can see in the hello packet the important field is just subnet mask, hello interval information, priority, router priority, this is the again priority of interface. Then router dead interval, right? Means hold on time is 10 second and hello time is 10 second and hold on time is 40 second. Router is sending hello message after every 10 second and neighbor router is storing that for next 40 second. The dead interval means dead time. After that, DR router information and backup DR router information, designated router ID and backup designated router ID. These are fields of your OSPF hello message. Here we don't have anything important for now, just keep it close. See, out of this information, the must match information is over here. First of all, area ID. Area ID must match. How two routers can become neighbor in OSPF? For that, first parameter is area ID R1, R2. Here IP address is 12.1/24. Here IP address is 12.2/24. Okay, my OSPF, here my OSPF process ID 1 is running. Doesn't mean the process ID is locally significant, right? It should not match. You can configure same or different on the router, doesn't matter. Even routers doesn't exchange process ID in the hello message. We have seen this. Okay, this is locally significant. OSPF process 1 or process 2, 10, 20, you can enable any process on router number 2. Then this interface is also in area 0, this interface is also in area 0. For neighborship, first parameter is area ID. Area ID must match, must be same. Let's suppose on router number 1 you have configured area 0, and on router number 2 you have configured area 1. Will OSPF neighborship come up between R1 and R2? Answer is
No.
No.
no, right? Even you can try with this on router number, even I have not configured R2 till now. So IP OSPF neighbor, you can see we don't have any neighborship. If I will configure R2 also, interface F0/0, no shutdown, and IP address 12.1.2 255.255.255.0. One more thing which you can see here in the hello message is in the OSPF hello packet, DR router ID, backup designated router ID 0.0.0. It means what? It means there is no any BDR till now. When router 2 will come up, maybe router 2 will become BDR, and the router ID of router 2 is going to be BDR router ID. So router will start carrying that information as well in their hello message. For now, BDR router ID is 0. Router OSPF process ID 1, network 12.1.1.0, wildcard mask 0.0.255, and area 1. Now both the routers are sending hello message. Here you can see the router 2 will also start sending hello message. Earlier only router 1 was sending hello message. Here is the first hello message of router number 2. If you will open hello message of router 2, what it's saying? Area ID. And what is the area ID? 1. See, area OSPF area is represented in IPv4 format. If you are going to configure area 0, it will be 0.0.0. If you are going to configure 1, it is going to be 0.0.1. Either you can configure area like this or like this in decimal. It will automatically convert in IPv4 format. If I will configure area 256, then what will be area ID in IPv4 format? 0.0.1.0,
1.0.
right? 257
1.1.
0.0.1.0.1, like this. Okay, the area represented in IPv4 format. Okay, so now, okay, router 2 is saying my area ID is 1, and router 1 is saying my area ID is 0. Rest all the things are same, but still they cannot form neighborship. Here you can see you are getting the log message as well, error log message. What it's saying? Received invalid packet, mismatch area ID from backbone area. Backbone area must be virtual link. Okay, you will understand this also later. Here we are getting area mismatch error on the console of router number 2. On router number 1, we are not getting any message. Later you will understand, like area 0 is the backbone area, and rest all the area 1, area 2, 3, 5, 10, 100, 200, 500, 1000, all other area are called regular area. And two regular area can never communicate, right? between two regular area, backbone area must be there, area 0, right? We'll understand that later. First understand the basic neighborship parameters. So here still we don't have neighborship because area ID is not same. I'm going to correct it. Say no here and configure the network with area ID 0. As soon as I have configured area ID 0 here, you will get one log message for OSPF on router number 1 and on router number 2 on both the router. And here you can see the log message, what it's saying: new adjacency form neighbor 12.1.1.2 on fast ethernet 0/0. So router 1 has discovered one neighbor finally on 0/0 interface, and the IP address of neighbor router is 12.1.1.2 from, and state moves from loading to full. So loading, full, these are OSPF neighborship states. We'll understand that with the help of types of messages in OSPF. Okay, what others? Now if you will open any new hello message, let's say here is the hello message of R1 is sending this hello message to R2. Now you can see BDR router ID's information is also there, BDR router, and one more field is added, that is active neighbor field. Earlier this field was not there, right? Earlier DR router and BDR router information was there. BDR was 0.0.0. Now BDR is 12.2. Router 1 is the DR, 12.1. 12.2 is the BDR. Not router is going to become DR or BDR. Interface of router will become DR or BDR. So the interface with IP 12.1 became DR, and the interface with IP 12.2 became BDR. And here is active neighbor information as well. Means router 1 is sending this hello message. You can see source IP 12.1. It means it is telling to their neighbor that, bro, there is bidirectional connectivity. I know you, right? I know my neighbor. You are my neighbor, active neighbor. Okay, it is like this to check just bidirectional connectivity. So here again, if I will open the hello message, you can see first important field is area ID. Area ID must be same, must match, then only neighborship will come up. Second parameter, if you have configured the authentication, then definitely authentication type and authentication data should be same. Authentication type means if you are using MD5 authentication one side, then other side also you have to configure MD5 authentication also. It supports multiple algorithm. I will show you that. Okay, but if you have not configured authentication, then authentication doesn't matter. Area ID should be same. Second, subnet mask. Subnet mask must match. If subnet mask is not going to match, see here, subnet mask must match. What subnet mask I have configured here? 12.1.1 255.255.255.0. That's why. So IP OSPF neighbor. Here you can see in the neighbor table we have information of neighbor, right? All link state routing protocol maintain neighbor table to store the neighbor information. Here the neighbor IP address is 12.1.2. Priority is 1. State is full. Neighbor is BDR, right? The date interval of this neighbor is 38 seconds, but after 10 seconds it is again going to receive hello message and it will reset the time. Address of neighbor and the interface, on which interface it has discovered the neighbor. This is neighbor information. If I am going to change the subnet mask on any router, go to R2 interface F0/0 IP address 12.1.2 255.255.255.128, right? So tell me, can router 1 ping to router 2 now? Can ping work? Reachability is there. Ping 12.1.2. Ping is working. Yes, working. So IP OSPF neighbor. Is neighborship there? Yes, neighborship is also there. Praful, you said subnet mask must match. So IP OSPF. So IP OSPF neighbor. Is neighborship there? No. Here what is the date interval? 19 seconds. After 19 seconds, router 1 is also going to flush this neighbor information. Now you can see in the neighbor table nothing is there. Why we don't have neighborship? How you will troubleshoot? You will check so IP OSPF interface brief. You will see okay, process ID is 1, area ID is 0. On router number 2 also let me check. So IP OSPF interface brief. So IP OSPF interface brief. Here also process ID is 1, area ID is 0. There is connectivity. Yes, there is IP connectivity as well in between R1 and R2. Then why OSPF neighborship is down? So IP OSPF neighbor. Why we don't have neighborship? Because of subnet mask. Here you can use this command show IP OSPF interface fast ethernet 0/0. This is the command to check the detailed information of OSPF routing protocol on an particular interface. Okay, like
It was already visible when you see when you typed you saw slash 25. There was a slash 25 on the other side, and the other side when you type show IP OSPF interface brief, it shows the mask address. You see slash 25.
it's not same na, that's why neighborship is not there.
What about on the other side, on router 1?
24.
You see, that's probably why it's a problem, no?
Yes, that is the problem only. Okay, this is the command to check the detailed information of OSPF routing protocol on a particular interface. Like here you can see the status of your interface, admin status and line protocol, then IP address and subnet mask, area ID, right, attached via network segment, process ID, router ID, network type. You are also going to learn different types of networks in OSPF. OSPF network type is broadcast. Cost on the link on fast ethernet 0/0 cost is 1. Then here also cost shutdown, and after that state is DR, priority, designated router ID, interface IP address, hello interval, dead interval, wait interval, retransmit interval, and last one again leave these all things. So these are important troubleshooting component. Like whenever you will be troubleshooting the issues, you can use this command. Many time even in our class we are going to use this command for troubleshooting, right, to check the network type. If network type will not match, then also OSPF neighborship will not come up. Okay, so again on router number 2 also I will use this command. So IP OSPF interface fast ethernet 0/0. So this will give you the detailed information, and so IP OSPF interface brief will give you the summary information, right? Here you can see slash value 25, here you can see slash value 24. That's why OSPF neighbor is down, not up. If you will check so IP OSPF interface brief, then also you can get summary information, interface brief, summary information. And here also so IP OSPF interface brief. So IP OSPF interface brief. So what you will verify here with the help of this command, that area ID must be same, right, and subnet mask must be same. Third component or parameter which must match is hello time and dead interval. There is no any requirement of hello time and dead interval in EIGRP, but in OSPF hello time and dead interval must be same. Can anyone tell me the command to change hello time? Hello and dead interval must match. If I am going to configure correct subnet mask now on router number 2, if I will correct the configuration interface F0/0, again my neighborship will come up soon. So IP OSPF neighbor. What was happening? Router 2 was sharing subnet mask 255.255.255.128 in their hello message, and router 1 was sending /24, right? So the subnet mask was mismatched. That's why neighborship was down. Now again you can see the log message, and so IP OSPF neighbor, again your neighbor is up. Here you can see this state, this should be full. Sometime it will be two-way state, right, but that is not a problem. between DR and DR other. Later we are going to learn the neighborship, OSPF neighborship. So if neighborship is in two-way state, sometime it can be issue, sometime that will be the normal situation. But if neighborship is in full state, that means all the database, each and every update is exchanged. Everything is exchanged, means routing table is updated, database is exchanged. When routers will exchange database with neighbor, then state will move to full state. Then any other requirement, okay, subnet mask, dead interval, then nothing. If you have configured authentication, then authentication type and authentication data must be same. And one more thing, network type. For now, just I am writing it over here. Later we'll understand this. What is network type? And here, even between router 1 and router 2, whenever you have this kind of scenario, point to point link, you should change the network type. You will not leave it on default network type. Like here, unnecessary router is maintaining DR and BDR information. Okay, if I want to avoid the DR and BDR, router, if router is performing DR BDR election, it will use their CPU only. Here DR BDR is not required. Later you will learn this. To avoid that, we can simply change the network. IP OSPF network point to point. Now, so IP OSPF neighbor. Here you can see now there is no DR and BDR. There is no DR and BDR. Here again neighborship is fluctuate, and here also you have to change the network type. Otherwise, neighborship is here, but database will not get exchanged. Database will not get exchanged. If I will create any loopback on router number 1, interface loopback 1 and IP address 10.1.1.255.255.255.0, router OSPF 1 and network 10.1.1.0, while karma 0.0.255 and area 0. Here you can see, so IP OSPF database, it has installed this network in the database. Like in this LSA, you will find that subnet. Let me open the database in detail. So IP OSPF database, and then here I can say router LSA of 12.1.1. You will understand this database in detail. Don't worry, just wait. Here you can see it has added the link information. What I told you, it is going to store the state of link in their LSDB, right? So how many links are there on router number 3? 3. And this is the first information of first link, second link and third link. Actually it is considering their neighbor also as a link. 12.1.2 is the neighbor. So 3 links are there, and here you can see the information of link. Like on link, network type is a stub network, then subnet is this one. Subnet is 10.1.1.1, but what I have configured is the subnet which I have configured? No. On the loopback interface, by default OSPF advertise prefixes with subnet mask /32. Okay, on the loopback only. Even you can change the network type. On by default network type on loopback interface is loopback only. If you will change it to point, it will store /24 subnet mask. Then what is the network running on this link, on this stub network? What is the subnet mask and what is the metric? For all the link it has same information. This is what database. It will advertise database to router number 2, so IP OSPF database. But here you can see the database of R1. If you will open it in detail again, router and 12.1.1, 10.1.1.0. Is network type same? Okay, route is present in the database, so IP route OSPF. You can see it has not installed 10.1.1.0/24 in their routing table. Prefix is present in the database but not in the routing table. In database you can see 10.1.1.1, but why it is not in routing table? Because network type is not same. So if network type is not same between the router, maybe your router will become neighbor. They can have Neighborship in full state database is exchanged, but route will be not installed in routing table. So IP OSPF neighborship is in full state. And here you can see as network type on router number 2 is broadcast, router 2 is still performing DR and BDR. Now router 2 is your DR and router 1 is BDR for R2. For R1 there is no any DR BDR required. So DR BDR depends on OSPF network types. Here if I am going to change network type again on F0/0 IP OSPF network point to point, then you can check the routing table again. So IP.OSPF, now you can see just it will install the 10 subnet. You can see 10.1.1 is installed in routing table also, right? So network type should be also same. These are the parameters, hello parameters of OSPF. Ask if anyone have any question.
Hello, can you hear me?
Yes. No question. Let's
Sir,
start.
I have a question that you mentioned that there is the area we need to define by two ways, right? One decimal format, one is IP format. So what is the conversion calculation here? Means, I don't get actually.
You didn't get this conversion.
Yeah. So this is the limitation from 0 to 255, or it's, how many area we can define in total? Is there any?
2 power 32.
Okay. So what is the calculation? Means suppose I am defining 300 in area, then how to I convert into the in the IP format, in the productive format? What is the calculation behind it? Means
0.0.0 means what?
zero, I guess.
0. 1 means,
Area 0, 1.
and 255 means, and
Area
256 means.
255.
You know this? How it is 256?
No, sir.
Yeah.
This is my question actually.
Go with subnetting, bro, once again. Watch the
Okay.
subnetting recording. This is subnetting.
Once you go over slash
Just we are
24, you
converting.
hit another network.
Correct. 250,
Yes.
256 is not valid IP. In each octet,
Yes.
we have only 8 bits value. So value can be from 0 to 255. Right? Like in subnetting, we had
So
solved this subnetting question 10.0.0.0 slash 10, let's say. What will be the first network ID?
The 10.0 one is
First network ID is
10.0.0 to
10 dot,
1.
and second network ID
Yes, it was, I forgot,
it
sir,
is
actually.
64, bro. 64. So what will be the last IP address of this subnet? First subnet?
63.
Dot 63.
63. Yes, sir. Yes, sir. 63.
10.0.0.63. Then next subnet. Is it correct subnetting?
No, 10 dot.
No, actually, it will go for the 10.63, I
Leave
guess.
it now. Just go through
Oh,
subnetting once. You will understand this. Like how 256 is 1.0. Okay. We have covered. Just watch the subnetting
okay,
recording once
fine.
again.
Okay. Okay.
Okay.
I have another question.
Go ahead.
For the network type, what's the multicast address for the point-to-point and the point-to-multipoint in OSPF?
Network type and multicast address.
Yes, you said when we do uh,
I said DR and
so
BDR depends
OSPF.
on types
Yes,
of
correct,
network.
right? Yes, yes. But then you mentioned the network type. Sorry. Yeah, what I'm trying to say here is we have two multicast addresses, right?
Mhm.
Um, one is .5 and other one is .6. And you said when it's doing by default is doing broadcast, right? So it's using .5,
Not broadcast, multicast.
right?
I said all OSPF router
Sorry,
listen
my
on
bad, my bad.
.5
Multicast.
and DR and
Yes.
BDR listen on .6. So if there
Okay.
is DR router
So
and BDR router in your network, then that routers will be listening on .6. And DR and BDR election will happen or not happen, required or not required, that depends on network type. That was my
okay,
statement.
then okay, okay. In that case, when we do point to point, we don't do DRBDR. So what is the multicast IP then he's going to use?
.5.
Okay, thank you. Okay, okay.
Anything else, guys? Okay. Let's understand with
Sir,
OSPF messages.
sir, why you use wildcard mask? Hello,
We use
am I
wildcard
audible?
mask to define the must match bits. 10.1.1.0 and wildcard mask 0.0.255. So here in this wildcard mask we have 24 zeros. Zeros means must match the prefix. Okay, so it will enable OSPF on that interface where these bits will match. Like let's say I have a router. This router has two interfaces. Okay, here my network is 10.1.1.0/24. Here my network is 10.1.2.0/24. I want to enable OSPF over here. I will run command router OSPF 1 and network 10.1.0.0 wildcard mask 0.0.255.255. It will enable OSPF on both the interfaces. Why? Because this wildcard mask is telling to match 16 bits, right? Means first octet value and second octet value. In first octet the value is 10, in second octet value is 1. Then enable OSPF. Value in these two last octet doesn't matter. So through wildcard mask we are defining how many bits must match. Instead of saying 0 here, if I am going to say 10 and here 0, will it enable OSPF on any interface? Will this command enable OSPF on any interface of R1?
No.
No, it will not enable because the wildcard mask is telling to match 24 bits and there is no any interface on router number 1 where these 3 octet values are matching. Okay, so through wildcard mask we are matching the number of bits. Clear, brother? Types of messages in OSPF. Through messages only we are going to understand a state, we are going to understand other types of messages and database exchange between routers. Very first message is called type 1 message. Type 1 message is your hello message. Hello message is used to discover neighbor and keep alive. Type 2 message is DBD message. DBD stands for database description. This is not the database actual prefixes, but these are the header. This is the header of prefixes, like similar like menu card of any hotel. Menu card of hotel. Menu card carry the name of all foods, but these are not the actual foods, right? If you are going to order request for burger, you will get burger and you can get the name of all the available foods in hotel in the menu card. So menu card is description of foods. Similarly, DBD is description of database. Router 1 is going to tell to router number 2 that bro, I have 10 network, I have 20 network, I have 30 network, but note the complete information of those network, because to calculate the metric, complete informations are required, like cost is required. So if router 2 will request for the detailed information, then router 1 is going to send detailed information first. They will exchange the empty database or header of database, that is DBT. It is like this. I have two router R1, R2, both are connected together. My routing protocol is OSPF. Okay, and one more thing about hello message, let me write here. Hello message. Hello message used to discover neighbor. Second, keep alive. Router sends multicast address on 224.0.0.5. And in case of static neighborship, unicast. Otherwise, always multicast. So, unicast in case of static neighborship. EIGRP also sends unicast hello message in case of static neighborship. In dynamic neighborship, it sends hello message on multicast address. Similarly, OSPF also sends hello message on multicast as well as on unicast. And we had seen the content of hello message: version, type of message, length of message, router ID, checksum, authentication type, authentication data, dead interval, hello interval, priority, DR router ID, BDR router ID, and neighbor router ID. This was the information inside hello message. And what I told you, parameters are hello time, date time must match, area ID must match, and one more thing, router ID must be unique. Here in the hello message or neighborship parameter, you can add one more statement. Router ID must be unique. If two routers have same router ID, again that is going to be issue. See here on router number 1, first if I will try to change the router ID here, it will not allow me to do that. Router OSPF1 and router ID, let me say 1.1.1. What it's saying? Reload or use clear IP OSPF process command for this to take effect. Reason: router ID is the identity of database. All routers in OSPF domain maintain database and they exchange the database. How they represent their database? With the help of router ID only. And router 1 has already shared their database with router number 2. Router 1 already shared their database with router number 2 with their neighbor. And there it has here router ID 12.1.1. Earlier router ID was 12.1.1. That's why you are not allowed to change router ID now. Once OSPF router discover neighbor, they have neighborship established. After that, you are not allowed to change router ID. On router number 2, if you will check, so IP
Sir,
OSPF.
how router ID decided like what will be the router ID?
Wait, no, brother.
Okay. Thank you.
On router number 2C, if I am checking OSPF database, then here you can see there are two databases. Like this is the database of 12.1.1 means router number 1, and this is the database of, actually this is single database, but there are two types of link state database, right? Database of R1, database of, this is LSA, router LSA of R1, router LSA of R2. In the router LSA of R1, there are three links: In the router LSA of router 2, there are two links. Here you can see the checksum, sequence number, and advertising router ID. Who is advertising this LSA? If I will clear OSPF process once, okay. Till now I have not configured the router ID here. Do clear IP OSPF process. Say yes, and then you can change the router ID. Now I have set router ID here 1.1.1. On router number 2 I am going to change it to 2.2.2. router ID 2.2.2.2. do clear IP OSPF process, yes, and router ID 2.2.2. Just 1 minute, guys. Hello.
Haruna,
Yes.
Haruna,
Yes.
I'm planning to take CCNA and I have
Okay.
already booked. So can you write me on WhatsApp? I need to
No
check with
problem.
you some things.
But
Okay.
I don't have a number. You know how to text me on WhatsApp? Text me on WhatsApp.
I couldn't find you on WhatsApp. Like if you can write me a message, I'll write me a message.
Okay.
Okay.
On router number 2,
Okay.
my router ID is 2.2.2. On router number 1, my router ID is 1.1.1. So IP OSPF neighbor. Here you can see actually this was not the IP address. This was the router ID of neighbor. Router ID is not routable. Right? This is identity of router. Now on router number 2 you can see who is neighbor 1.1.1. If you will check now database, so IP OSPF database, then you can see it has here their database with this router ID. In OSPF we have multiple types of LSAs. Actually we have total 12 types of LSAs, and in each and every LSAs these two things are common: advertising router ID and link ID. In all LSA you will find these two things: link ID and router ID, most important field of database. In some LSA both is going to be nothing but a router ID of router. In some LSA it is going to be the IP address. Later you will learn different types of router like DR router. Sometime link ID can be the IP address of DR router. You will learn AVR router. Sometime link ID can be the IP address of AVR router, area border router. Sometime link ID can be ESBR router IP address. But in router LSA, the very first LSA, both are router ID of router. And advertising router ID will be the always router ID of that router who is advertising that LSA. Advertising router ID is going to be same in all the LSA. Router ID of router who is advertising that LSA. So router ID must be unique. On router number 1, if I will configure same router ID, router OSPF1 and do clear IP OSPF process, say yes, and router ID 1.1.1. Now you can see on both the router I have configured same router ID, right? And here it has started giving me the again error message: detected duplicate router ID 1.1.1 from 12.1.1.1 on fast Ethernet 0/0. From router number 1 it is getting detecting duplicate router ID. Again here if you will check the neighborship, here also we have same log message. So IP OSPF neighbor, then you can see neighborship is showing what? Clear. So IP OSPF, neighbor. On router number 2 we are not able to find the neighbor, but on router number 1 it's showing because dead interval. After 7 seconds you can see neighbor is expired. It has flushed the information. Now you don't have neighborship between R1 R2. This time why we don't have neighborship? Because of duplicate router ID. So as router ID is the unique identity of router used to represent their database, it should be unique. Okay, again router OSPF1, and this time I am allowed to change router ID because there is no any neighbor of R2. So until and unless router has not discovered the neighbor, you are allowed to change router ID. When you are not allowed to change router ID, when router has shared their database, send their database to neighbor, router ID 2.2.2.2. Again neighborship will come up, and OSPF hello message also share the router ID information. Okay, so guys, see in neighborship parameter we have seen router ID must be unique, hello time date time must match, subnet mask must match, even MTU must match. Here I have not mentioned few things, I can add that also. MTU size also must match. If MTU is not same, then your neighborship will not like the neighborship will stuck in X start state. Soon you are going to learn that also, because in hello message we have not seen MTU information, right? In hello message we have not seen MTU size information. If I will open any hello message, here you can see, is MTU size there? No. Router is not exchanging MTU in hello message. Router will exchange MTU in DBD message. In which message? DBD message, the second message of OSPF, right? Second message carry MTU information, and if MTU is not same, then again neighborship will stuck. So MTU also match, authentication type, authentication data also match. Then later you will also learn the flags, some flags, and in that case flags must match, flag bits must match, area ID must match, and network type must match. That's it, these are the criteria. Let me tell you few things about router ID, and then I will come on second types of message, that is DBD message. Before DBD, understand router ID. What I told you, what is router ID? It is 32 bits address represented in IPv4 format. It is an 32 bits unique identification of routers, of router database in OSPF domain. Router ID play very big role in OSPF, and there are two ways to assign a router ID on router. First, manual. Like here you have seen manually how I have configured the router ID on router. Another way to allocate a router ID on the router is dynamic. If you will not configure router ID manually on the router, then router is dynamically going to elect router ID. Here see, on router number 3 I am going to configure some loopbacks, and I will enable OSPF. And tell me one thing first, if there is no any IP address configured on the router, in that case if I have enabled the OSPF protocol, then how router will elect router ID?
Process will not start.
Active interfaces. Loopback.
If no
If
loopback
active
exists,
interface, right?
see like on this router,
Active interface.
so IP
I
interface
interface.
brief. This router doesn't have any IP address on any interface. If I will run command router OSPF1,
It will fail.
no, it will take the command.
Highest
It will fail
IP.
to restart the process, but OSPF will get enabled on router. See here, command is accepted, and here I got one message, OSPF process 1 failed to allocate unique router ID and can't start. If you will check protocol, do so IP protocol, you will see router ID 0.0.0. Router ID is 0.0.0. Always remember, OSPF doesn't work with router ID 0.0.0.0. This router ID is reserved, not huge. Okay, now let me remove OSPF from here. No router, OSPF 1. In dynamic way, manually we can configure the router ID. That is going to be easy. Router OSPF 1 and after that router ID. In dynamic, how it will elect the router ID. For that, first your router is going to check loopbacks. What it will check? Loopbacks. Loopback. If loopback exists on the router, then the IP address which is running on loopback will become router ID. What I am saying? If loopback exists on the router, then the IP address which is running on loopback interface will become router ID. What if multiple loopback exist on my router? Interface loopback 1, IP address 1.1.1, 255.255.255.0. Interface loopback 2, IP address 2.2.2.2 and 255.255.255.0. In that case, what will happen when we have multiple loopbacks?
The highest IP
Highest
loopback
loopback.
IP.
The
That
highest,
becomes
Highest loopback
router
IP address will become
router ID.
router ID. Correct. Absolutely right. So here I can say in dynamic, highest loopback IP. Loopback IP will become router ID. If loopback doesn't exist on the router,
Non-valid
Highest
router
interface IP.
then router will check physical
interface.
interface IP. Again, if I have multiple physical interfaces configure on the
The
router, then
highest IP address becomes the router ID.
again highest IP address on the physical interface of router. And if IP is not configured, then 0.0.0. So on router number 3, I have two loopbacks. You have seen this. Do so IP interface brief. 3 loopbacks are there. I'm also going to configure interfaces. Interface F0/0 no shutdown and IP address 10.1.1 255.255.255.0. Interface F0/1 or 1/0 no shutdown. IP address 20.1.1 255.255.255.0. I think line protocol of these interfaces are done. Will not work. Let me see. Router OSPF 1 and do so IP protocol. We use this command in all dynamic routing protocol in EIGRP, BGP, OSPF, right? Gives the information of routing protocol. Routing protocol is OSPF 1. No any filtering, incoming, outgoing, and here you can see the router ID. Router ID is 3.3.3.3. This is loopback interface IP address. This is highest loopback interface IP address. And if I am going to see here no loopback 1, no interface loopback 1 2 3, no loopback 2, no loopback 3. Now loopbacks doesn't exist. What will be the router ID here on router number 1 now? What is my router ID on router number 3 now?
It will be 0.0.0. No, after clearing, okay.
I think you have already configured the
See, a
IP
router
address,
is
I
going
think.
to elect router ID once. If router ID is elected, right, 3.3.3. Now let's suppose I am creating any another loopback. Loopback 10. IP address is 10.10.10.10. Router ID will not change, right? If router ID is elected, doesn't matter the interface is up or down. Interfaces is deleted or available. Doesn't matter. Router will be using that router ID until and unless you will not clear the OSPF process, right? So this router can work with this router ID. Doesn't matter this loopback exists or not. It is like the manual configuration. Like manually, if I have configured 3.3.3, router is not going to check even this router ID is running somewhere on any interface or not. Now router OSPF know one thing, that my router ID is 3.3.3. That's it. right? So interfaces IP address checks happens only during election for router ID. Once router ID is elected, after that router will be using that router ID only. Now, see, there are two things. First, types of message. In types of message, we have seen the hello message. Second message is DBD message. Type 3 message is your LSR. Like router, what I told you, a router is going to send description to their neighbor, and neighbor will send link state request, right? Let's suppose a router has 10 dot, router 1 has 10.1.1.0, 10.1.2.0, 10.1.3.0/24. So router 1 has just given the description of these prefixes. If router 2 will send request, then router 1 will send the detailed information, right? If router 2 will send request for 10 and 10.1.1.0 only, then router 1 will send that prefix only. So LSR, LSAC, which is the actual update message. Type 4 LSU, and type 5 the last message LSAC. So request, update, and acknowledgement. These messages are used to exchange the database. Now, to understand these all types of messages and state, side by side we have to understand states as well. These are messages, and here I am going to write states also. States, neighborship states. Let me take it over here. Okay, if I will talk about the neighborship state between two routers, here we can see the neighborship state is full, but before coming in full state, many things happens behind the scene. So IP OSPF neighbor 2.2.2 neighborship is in full state, right? Understand all the other state. First state is down state. Neighborship states. First state is down state. What it mean? Anyone have idea about down state? Then init state.
Questions not configured.
Attempt state. For now I can remove attempt, later we can include that. For now, after init, two-way state. Then
X start.
X start state. Then
Exchange.
exchange state. Then
Loading state.
loading state. And after that,
Full state.
Final state, full state.
full state. See, your first message, the hello message. Hello message, router sends hello message in all the states except down state. Router can send hello message from init to full bay in any state. But these messages, other messages, will be sent in any specific state. 1 minute. Before I will explain these state, if anyone have any idea about these state, please explain, guys.
Sir, we have seen one state, like if I correct, like
Attempt.
wait, like wait. Uh,
Wait.
I can.
No, that
Okay.
was another thing. No
Okay.
worry, you will understand that also. Waiting for DR and BDR. That was the state for DR and BDR, not the
Okay.
neighborship state. Right now we are understanding the neighborship state.
Okay. Okay.
Anyone have idea about these states? Okay. Before us understanding states, understand one thing that in OSPF we have two types of neighborship. Number one, types, or I can say types of neighborship. We have two types of neighborship. First one is neighbor without neighbor without adjacency. Means this neighborship is going to be in two-way state. Neighbor without adjacent means, like, if I will give you the real example, then you guys often seen like some neighbors, with some neighbors you exchange everything, like even foods, right? Whenever you cook something special, you exchange with neighbor, and with some neighbor hardly you talk, right? When things are matching, thoughts are matching, then we exchange everything. When thoughts doesn't match, we don't even talk, but we are still neighbor. Similarly in OSPF, some neighbors will be only neighbor. They will not exchange anything, any routes. And with some neighbors, routers are going to exchange everything. That is neighbor with adjacent. Neighbor with adjacency. That is OSPF neighborship adjacency, means the full estate. Full estate. And neighbor without adjacent means neighborship in two-way estate. These are two types of neighborship. If whenever you say neighbor in two-way estate, it means there is no adjacency. Means router only knows that okay, that is my neighbor, but they didn't exchange any, don't exchange any, doesn't exchange any update. Means prefixes. Update means what? Prefixes only. And router exchange prefixes with adjacent neighbor, right? With when we have full neighborship. Full neighborship means if neighborship state is full, it means all the databases already exchanged. Okay, understand all the state one by one. Very first is down. Down means maybe you have enabled OSPF on any interface, but that interface is administratively down, or the line protocol of that interface is down. Then OSPF state is also going to be down. Means interface is down. As soon as you will enable OSPF on the router, on the interface of router, an interface will come up. The very first state is going to be your init state. Init stands for initialization. Means router will start
Sir,
sending.
so does that mean we never see a state called down? Because if you don't enable OSPF, we can't. If you don't enable OSPF, you put so IP OSPF never. Nothing will be there. So when we can see something called down.
So if OSPF is not enabled, then how OSPF state will come there?
Yeah, no, it will never come. So down will be the
Down
state
means we
when
have
only.
enabled the OSPF, but
Okay.
the interface is down, or their line protocol is down. OSPF is
Okay.
enabled.
Earlier they are into full state, and later by some reason the interface went down. Then we can see it as a down.
Correct.
Okay. Okay. Thank you.
Init state is the very first state, initialization state, where routers start sending hello message. In init state, init routers, router 1, router 2, both the routers are going to send hello message. And you know what will be the information inside the hello message? Content of hello message. Router 1 is going to send hello message to router number 2. Router 2 is going to send hello message to router number 1. In case of static neighborship, later we'll configure static neighborship as well between two routers. Your state is going to be attempt. Here, instead of init, that will be attempt. In most of the cases, state is going to be init. Okay. Now, the next state is two-way state. Init means initialization. Next state is two-way state. In two-way state, you can see both the routers are exchanging hello message. In the hello message, see in the first hello message of router number 1, let's say router ID of router 1 is 1.1.1 and router ID of router 2 is 2.2.2. In the first hello message of router 1, router will only send their own router ID, that hey, my router ID is hello, my router ID is 1.1.1.1. Router 2 is also sending hello message and my router ID is 2.2.2 and the other informations. My router ID 2.2.2.2. Tell me, through this hello message can bidirectional connectivity checked? No, right? Because there is no any information of neighbor. But when router 1 will receive hello message from router number 2, again it is going to send hello message after 10 seconds. In that hello message, router will send their own router ID as well as
Neighbor's ID also.
neighbor router ID. My router ID is 1.1.1 and my neighbor router ID is 2.2.2. When router will receive this hello message, bidirectional connectivity checked. Now router 2 can understand that hey, router 1 already know me. Router 1 already have information about me. Here router ID is not 1.1.2, it's 2.2.2. Correct it. 2.2.2.2. So in two-way state, actually routers check their own IP address, right? In the hello message of R1, router 1 will look up for their own IP address. Like here, if I will break the neighborship between router 1 and router 2, go to R1 and break the neighborship. Clear IP OSPF process and say yes. OSPF process is cleared. Here is the first hello message of router 1. If this is the first hello message of R1, then here you will not find neighbor router ID. Here you can see active router ID information is there. It means this is not the first hello message. If you will check this hello message, check active neighbor information is there. Yes, there. This is also not the first hello message. What about this one? Active neighbor router ID information is there. But in first hello message, there will be no any neighbor information because router 1 don't know who is router 2 or 2.2.2. So in two-way state, router checks bidirectional connectivity. Means router finds their own router ID in the active neighbor field. Similarly, one router 2 will send hello message. It will also share their neighbor router ID, that my router ID is 2.2.2 and my neighbor router ID is 1.1.1. Means I know the neighbor. As soon as router will find their own IP address in the hello message, state will move from Two-way. So in two-way state, what happens? In this state, bidirectional connectivity checks happen, right? Router check bidirectional connectivity. At the same time, DR and BDR election happen in this state. DR and BDR. Because for DR and BDR election, whatever informations are required, whatever parameters are required, those are already exchanged in these hello messages. So DR and BDR election will happen in this state. Now, Praful, why DR and BDR required? Let me tell you that. Let's suppose I have a multi-segment network or broadcast network. Nowadays in LAN we are using Ethernet, right? Ethernet means MAC based forwarding. See, if you are going to connect 4 routers directly with cable, that network is less scalable. But if I am using a switch in between to connect 4 routers together, this design is more scalable because here we have more interfaces available on the switches easily. On the router, if you are going to connect all the routers together, you need lots of interfaces. But in this design, we need only one interface on all the routers. Let me correct it first. Router 1, router 2, router 3, and router 4. If I have a multi-access segment here like switch, a layer 2 switch connected with all the router, and my routing protocol is OSPF. Guys, remember there is huge difference between EIGRP update message and OSPF LSU, which is the OSPF update message. Why I am saying there is huge difference? Because OSPF update message carry the detailed information of link. OSP EIGRP update message only carry the prefix information. R1, R2, R3 and R4. This is my switch. Here my sub segment is or subnet is 192.168.1.0/24. So I have configured one IP address from this subnet on all the router. Let's say on router number 1 my IP address is 1.1. On router number 2 my IP address is 1.2. On router number 3 my IP address is 1.3. On router number 4 my IP address is 1.4. Right, I have enabled OSPF routing protocol. OSPF. So router 1 will send hello message to switch. Switch will send to router 2, router 3, router 4. Router 2 will also send hello message. Even all the routers are going to send hello message. They will exchange hello message and they will form neighborship. Tell me router number 1 will have how many neighbor? R1 will have how many neighbor? 192.168, or I can say router ID 2.2.2.2. 3.3.3.3, 4.4.4.4. Router number 2 will have how many neighbor? 1.1.1, 3.3.3 and 4.4.4. Router number 3 will have how many neighbors? 1.1.1, 2.2.2 and 4.4.4. And router number 4 will also have 3 neighborship with 1.1.1, 2.2.2 and 3.3.3. What is the issue here? There is issue of flooding. Can anyone tell me how? There is issue of LSA flooding. You know, router 1 has C. First of all, number of adjacency is used. Then put yourself on mute, bro. This is what? Number of adjacency. How many adjacency are there?
12. Correct?
12.
So each router has to form a neighborship with the
3
remaining, right?
neighbor. Each router has
6,
3
I think.
neighbor. Total we have 12 neighbor. There is
12.
a formula to calculate
N
adjacency
factorial, right?
here.
N factorial.
Huh? N?
N factorial.
N minus 1 by 2. right? Okay, Praful, what is the issue if we have lots of adjacencies? See, if I will add any prefix on any router, let's say if any prefix will come up on router number 2, 10.1.1.0 or 20.1.1.0/24, what will happen? R1 is going to update their database, right? Let's say their data, this is the database of R2, and R2 database has sequence number 10. Now you have added new prefix in on router number 2. So router number 2 is going to update their database with sequence number 11, and it will advertise the updated database to router number 1, router 3 and router 4. Now when router 1 will receive some new information, updated information, router number 1 is also going to update their database, and whenever there will be increment in sequence number, it will flood their database. Router 1 is also going to share updated information to router 3, router 4 and router 2. Router 3 is also going to flood their database to all the router 4 is also going to flood their database LSU to all the neighbors. Now here is one problem, that is flooding of LSAs. Whenever any prefix will come up or goes down, if you will set the port, any port in your network, or if you will up any port, in that case there will be LSA flooding. If there will be any change in the database, router is going to execute the algorithm. Which algorithm? SPF algorithm. So when any prefix will come up or goes down on any router, all the routers are going to execute SPF algorithm. When router will execute SPF algorithm, it will recalculate the best path, it will update their database and routing table. This is the issue in multi-access segment. It is similar like in a class. In a classroom, let's suppose 40 students are there, and principal came here and asking for, let's say, date. What is the date today? And if all these 40 students is replying, then there will be what? Flooding, yes or no? If all the 40 student is going to reply that, hey, today is 1st Jan, then that is what? Data is going to overlap with each other. There is flooding in the class. At that time, no one can exchange the other data. If 2% is talking with each other, these two students, right? At that time, they cannot listen to his friend words because of flooding. How we are avoiding this flooding in the classroom? How we can avoid this flooding in the classroom? By electing monitor, right? We can elect a monitor in the class. Monitor that, hey, if you are the monitor of class, you are going to talk to principal, and then you will share the information like important information to a student, or you will collect the information from students and then you will forward it to principal. This way we can avoid the flooding here, reduce the flooding in the class. Similarly, in this scenario, if you want to remove the adjacency, flooding and SPF algorithm execution, what you can do, you can make one master router here, and that master router is called DR router. DR stands for designated router. It is similar like your monitor, right? All the routers, let's say my router number 1 is DR router. How election will happen for DR? No worry, soon I am going to tell you. Now router 1 is the DR. So all the other router, DR other, will have full adjacency with DR router, and only adjacency neighborship without adjacency means neighborship in two-way state will be there between DR others. Like router number 2 is DR other, router number 3 is also DR other, and router 4 is also DR other. So DR others can never and ever exchange database because their state is two-way. Here we have seen the neighborship state. In neighborship state, do we have discussed any kind of route or update message exchanged till two-way? till two-way, routers are only exchanging the hello message, right? So routers have not exchanged any prefix information, any update message. In two-way state, router will be only exchanging hello message. Okay. Now, if I am going to add new prefix here on router number 2, router number 2 is going to update their database and it will send the updated database to the neighbor with full adjacency, means to DR router R1. R1 is also going to update their database and then it will send updated message to updated database to their other neighbors, means to router number 3 and router number 4. So see the LSA flooding. How many LSAs are flooded here? Only 2. One generated by DR other for DR and one generated by DR for other DR other routers. Right? So now all DR other routers are going to send updated information or any change to the DR, and DR is responsible to update all other routers, right? No DR other and DR other have neighborship. They cannot exchange any route. They cannot exchange any route. Clear? Why DR and BDR is required? Now tell me, between router 1 and router 2, is DR and BDR required? Between R1 and R2, if I have
No.
like this, is DR and BDR required here?
No, sir.
No,
No.
definitely no, right? Here we have only 2 routers. There is no flooding. If there will be any change on router number 1, definitely router 1 should update it to router 2. If there is any change on router number 2, definitely router 2 should update it to router number 1. But by default, if this link is Ethernet link, on the Ethernet link, OSPF network type is going to be broadcast. And on broadcast network type, DR and BDR election happens. DR and BDR required, right? DR BDR depends on OSPF network type. In some network types, DR BDR election not happen. In some network type, DR BDR election happens. Here you can see in this broadcast network, DR BDR election should happen, right? Here if you will configure network type point to point, there will be issue. Later you will understand that as well, when to configure what network type. For now, understand the requirement of DR and BDR, and after configuring DR and BDR here in this kind of scenario, how we can avoid the flooding. Here we have only 4 routers. Imagine if we have 10 routers in one segment. That is common in case of data center, right? In the big campuses, right? Let's say in a campus I have 10 buildings. At each building I have one router, and all the routers are connected through a switch like this. Still here is a issue in this design, like if switch fail, then all the routers will become unreachable with each other. But here DR and BDR is required. What is BDR? By the way, DR understood. See, what if monitor is absent? What if monitor is absent in the class? Then who will take responsibility of monitor? That is backup monitor. Similarly here, what if my DR router goes down? If DR is not available, for that one router is also going to become BDR. That is just backup. It will be listening everything, like whenever there will be any change on DR other router, it will update to DR as well as BDR. Actually, you know now what happens. Now whenever there will be any change, router is going to send update message on 224.0.0.6. And who is listening on this address? Only DR and BDR. Router 4 will discard the update message. Router 3 will also discard this update message, because these routers are only listening on 224.0.0.5, right? So all DR other router will send their message on their update message on this address, and then DR router will send on 224.0.0.5, because all other DR other routers are listening on this address, correct? So DR other router sends update message on .6 and DR router sends update message on .5. That's why I said 224.0.0.5 is listened by all OSPF router, but 224.0.0.6 is listened by DR and BDR only. Here my network type is what? So IP OSPF interface F0/0. What is network type?
Point to point.
Point to point. Is DR and BDR there?
No.
See, router interface has only joined this multicast group. If this interface is going to receive any message on 224.0.0.6, it will definitely discard. It will discard. It will not open and update their database. Right? So important thing over here is understanding the address, multicast address. When DR other is generating update message and when DR router is generating the update message. And this TR and BTR election happen in your two-way state only. And if routers are not able to elect DR router here, then what will happen? Neighborship will stuck in two-way state.
Two-way
Let me
state.
change the network type first. IP OSPF network broadcast. Now DR and BDR is required. Interface F0/0 IP OSPF network broadcast. Now DR BDR required. If you want any router to not participate in DR and BDR, then you can configure priority 0 there. Router interface with priority 0 never participate in DR and BDR election. If I want router number 4 should always be DR other, I can configure priority 0. For DR and BDR election, the very first parameter is priority only. Based on priority, routers are going to perform DR and BDR election. If I will configure priority 0 on both the router, IP OSPF priority 0, and on router number 1 also IP OSPF priority is 8 bits decimal value 0. Now see, so IP OSPF neighbor. See guys, this time this is the issue, right? Here in this case, if neighborship state is two-way between router 2 and router 4, let's say, or between router 2 and router 3, neighborship is two-way. That is normal scenario. Everything is good. But here, this two-way state is issue. Right? Because network type is broadcast. On broadcast network type, DR router must be there. And here we have configure priority 0. That's why no one is participating in DR and BDR election. That's why your neighborship is stuck in two-way state. Sometime interview is asking this kind of question. OSPF neighborship is stuck in two-way state. What can be the reason? Reason can be DR BDR routers are not able to elect DR router. Right? Now understand the election. Election criteria of DR. Which router will become DR? So whatever information is exchanged in hello message, based on that DR BDR election will happen. Because DR BDR election is happening in two-way state. Till two-way state, routers has only exchanged hello message. So for DR and BDR election, first router is going to check what? For DR and BDR?
Priorities.
Priority. Priority is 8 bits value, and by default priority is 1. Router with higher priority will become DR router. See, on router number 1 and router number 2, I am going to remove the command priority 0. Say no to this, and on router number 1 also I am saying no to this. Now tell me which router will become DR. Priority is same. So IP OSPF interface. So IP OSPF interface brief. You can see priority is, sorry, so IP OSPF neighbor.
Neighbors.
Priority is 1 on router number 2 also priority is 1. So which router became DR now here? 2.2.2 is BDR. Here you can see. It means 1.1.1 is my DR. So IP OSPF interface. So IP OSPF interface F0/0. Here you can see this router is state is
DR.
priority is 1, state is DR. This router is DR. But there is a timer for DR and BDR election, that is 30 second. 30 second or 40 second, sorry. Wait time is 40 second. When you will enable OSPF on any interface, router will wait for 40 second to declare yourself as DR. If router will receive any hello message with higher priority within 40 second or with higher router ID, if priority is same, then router ID will be used for DR and BDR election. Then that router will become DR. But if router is not going to receive any hello message with higher priority or higher router ID within 40 seconds, then router will declare themselves as DR. And on the same segment, later if any router will come with higher priority or higher router ID, then also DR router will not change. Okay, like here, see, I am going to in this case router 1 is my DR router. If I will remove OSPF, no IP OSPF 1 area 0, do so history. Do so IP OSPF interface brief. OSPF is still enabled. Do one thing, router OSPF 1, I think network command is running. Do so run section router OSPF, and under OSPF you have enabled this command. Say no to this. Do so history, and here also say no to this on router number 1. Router OSPF 1 and no. Now so IP OSPF interface brief. Okay, OSPF is only enabled on loopback interface, so IP OSPF neighbor. So IP OSPF neighbor. We don't have neighborship on router number 2 also. So IP OSPF interface brief, no interface. So IP OSPF neighbor. We don't have neighborship. Done. Let me configure R1. First I am going to configure higher priority on router number 2. Interface F0/0 IP OSPF priority 10. And on router number 1, interface F0/0 IP OSPF priority, let's say 5. So which router will become DR here? Here based on priority, DR BDR election can happen. R2 will become DR because R2 has higher priority. But if you will not enable OSPF on both router within 40 seconds, let's say on router number 1 I have enabled OSPF IP OSPF 1 area 0, and do so IP OSPF interface fast Ethernet 0/0 include state, or here you can see like this. State is waiting. It is waiting for DR and BDR election include state. It is waiting. It will wait for how long? It will wait for
40 seconds.
40 seconds.
40 seconds.
Within 40 seconds, if it will receive any hello message with higher priority or higher IP address,
Router ID.
yes, sorry, not IP address, router ID, then that router will become DR. Otherwise, here you can see this router is now DR. Now if you will enable OSPF on router number 2, IP OSPF 1 area 0, even router number 2 has higher priority, but router 2 will not become DR. Who is your DR?
R1.
Still R1, and R2 will become BDR. So IP OSPF
BTS.
neighbor. You can see 2.2.2 is
BDR router.
Okay, so if you want to avoid DR and BDR here between router number 1 and router number 2, then configuring parity 0 is not the solution, right? You will never configure parity 0. Like if you are thinking, okay, here DR BDR is not required, let's configure parity 0. No. Then you have seen neighborship is stuck in two-way state, and if neighborship is in two-way state, routers are not going to exchange routes.
Yeah.
So to avoid DR and BDR here, we have to change network type. For now, just keep in mind on point-to-point link, my OSPF network type should be point-to-point. IP OSPF network point-to-point. Now on point-to-point network type, OSPF doesn't perform DR BDR election, so IP OSPF neighbor, you can see, and neighborship is also in full state. Clear, sir?
Correct.
Okay, clear everyone?
Yes, sir. Okay.
Yes,
Let's
sir.
move to the next state. After two-way, init done, two-way done. Now bidirectional connectivity check done. DR BDR election done.
Sorry, sir, I was in mute. Sorry. So first criteria priority, sure. Then second day priority is same. Then it will go for highest router ID.
Correct.
Okay.
Priority. Then router ID. And router ID is unique. Router ID cannot be
Same.
same. Now, once routers has performed DR and BDR election, right, their state will move to X start. If state is in X start, it means in broadcast network type DR BDR election is done. In point-to-point network type, that is not required. Bidirectional connectivity is checked. In X start state, routers are going to exchange type 2 message. If someone will ask you type 2 message will exchange in which state, then remember in X start state. Before X start state, only hello message is exchanged. Here is your DBD message. Both the routers are going to share their DBD, database description. This is nothing but header of database. Header of database, like router 1 can say I have X network, Y network and Z network. If router 2 will request for any network, then it will send the detailed information. But some more thing happens in X start state, like exchange of sequence number. Routers will exchange sequence number here. On router, you can check what is the sequence number. So IP OSPF database, you can see the sequence number here. Sequence number of R1 database, sequence number of R2 database, right? Sequence number is represented in hexadecimal number. If I will change, add or remove any network information from the database of R1, like here you can see the 3 links are there. If I am going to down loopback, interface loopback 1 shut down. So IP OSPF database. Now you can see how many links are there. Only 2 links are there, and sequence number is, earlier it was E, now F. And earlier sequence number of R2 was 9. Sequence number of R2 is still 9. Okay. So sequence number will exchange in X start state. MTU negotiation will happen. Routers are going to negotiate MTU size negotiation. If MTU is not same, right, that is MTU should be same. If it is not same, sometime it can cause OSPF neighborship flapping, right? Because of MTU, sometime OSPF packet can be dropped, right? If fragmentation is not allowed, So in that case, what will happen? To avoid the flapping, we can set same MTU size, and that's why OSPF checks MTU size in X start state. If you want to ignore, you can ignore, but by default, it OSPF checks MTU size also, and if MTU size is not same, then neighborship will stuck in which state? In X start state. You can try to check it, like go to router number 2, and here, what is the default MTU? Interface F0/0. IP
1500.
MTU by default 1500. So let me configure 1400 here. I have changed the MTU and clear IP OSPF process. Now see, until unless you will not clear, OSPF neighborship will not goes down. Why? Because state is already in full, right? It MTU checks happen in the X start state. So IP OSPF neighbor, you can see neighborship is in full state. When router will rebuild the neighborship, then in X start state, this time it will stuck. Clear IP OSPF process and say yes. Now, so IP OSPF neighbor. Now you can see neighborship is stuck in which state? X start state. Why? Because of MTU mismatch. If you want to ignore the MTU, there is one command. Interface F0/0 IP OSPF MTU ignore. Right? After running this command, again your neighborship will come up. Now router will not check any MTU. Again you can see neighborship is in full state. Okay. So if someone is asking, my OSPF neighborship is stuck in X start state, what can be the issue, or you are troubleshooting, then check MTU. Must check MTU. Some more thing happens, like master and slab election happens here. Master and slab election, like which router is going to initiate exchanging database, which router will share their database first between R1 and R2. For that, there will be one small election of master and slab. One router will become master, one router will become slab router, and this election happen on the basis of what?
Sequence number.
No, on the basis of router ID. Router with higher router ID will become master. Router 2 will become master. Tomorrow I will talk more if you want on master and slab. You can ignore the MTU. After that, okay, these are the tasks happens in X start state. And DBD, this was empty DBD. The first DBD was empty DBD, like null update message in EIGRP. This was description and even empty description, right? Now after these tasks, your state will move in exchange state. In exchange state, routers are going to exchange the actual header, the DPD ls headers. Routers will send LSA headers, right? In X start state, empty LSA, empty database, and in the exchange state, the header, the actual header. And after that, after exchanging LSA header, state is going to move in loading, and all the database exchange will happen in loading state. In loading state, router is going to send LSR, link state request. In the response of LSR, router will send LSU, and U is the reliable message. So in the after getting update message, router will send acknowledgement, that is LS ACK. So LSR, LSU, and LS ACK exchanged in loading state, right? You will not see neighborship is stuck in loading state generally, because sometime it can stuck because of hardware issue, right? When routers are not able to exchange the database, or lengthy size of message, right? MTU is less, or right, router are not processing the OSPF packet properly, there is CRC error, packet loss. In that case, you will see hardly sometime you will see the state is stuck in loading. Otherwise, in loading state, routers will exchange the all update message, LSR, LSU and LSA, and when these three messages exchanged, after that state will move to full. So full means database is already synchronized, exchanged. These are the states. So here now I can ask you like hello message. Router send hello message in which state? In all state. Router send empty DVD message in which state? X start state. Router send LSA header in which state? Exchange state. Router exchange LSR, LSU and LSA in which state? Loading state. And after that in full state, router will be again exchanging hello message for keep alive. So here we have covered two things, neighborship states and types of messages. But the most important thing, the LSA is still pending. Tomorrow we'll break the LSA and you will see we have total 12 types of LSA. From CCNA to CCI we need to learn LSA 1 to LSA 7. Right, means total we need to learn 7 LSA, router LSA, network LSA, summary LSA, ESBR LSA, external LSA, MOSPF LSA is even not in use, that is multicast OSPF LSA. After that NSSA LSA. You need to learn LSA 1 to LSA 5 and LSA 7. Okay, we'll see that tomorrow. But all the LSAs will be exchanged in loading state. Now you know how two routers are going to become neighbor, how they exchange messages, and the state of OSPF neighborship. If state is stuck in two-way, you can verify it, troubleshoot it. If state is stuck in X start, again you can verify and troubleshoot it. Tomorrow we'll capture the link and then we'll see these headers. LSA's header.
Sir, in that empty DBT and extract, they are also not even exchanging the prefixes also.
No,
Nothing will be there.
it is similar like the null update message of PIGRP.
Okay, okay. And in DR other, like what will be the relation with BDR?
Full.
Like they are full.
Full.
Okay. Okay.
Okay. Tomorrow we will have one lab on DR and BDR as well. After that we'll see the router LSA. Router like LSAs of OSPF is the most important part of your OSPF routing protocol. Understanding all LSAs. Okay.
Sir, can are we covering like route redistribution between different protocols?
Why
like
not?
between OSPF to BGP? Okay.
Anything else, guys? Any question? Okay, then revise this basic concept of OSPF. Let's connect tomorrow and let's proceed from here.